Atomic structure. Here we'll discuss about definition of an atom, constituents of an atom, electron distribution on the orbit, definition and examples of isotopes, basic unit of matter. All matter is made up of tiny particles called atoms. Atoms cannot be seen even using normal microscope. Molecules are made up of atoms. Atoms of elements and compounds. Elements have similar atoms. Compounds have different atoms. What are atoms? Smallest particle of an element. Has all the characteristics of the element. May or may not exist independently. Takes part in chemical reaction. What makes up atoms? The subatomic particles such as electron, proton and neutron makes up the atoms. Subatomic particles. Electron. This is the subatomic particle with unit negative charge. Its mass is 1 upon 1836 of one hydrogen atom. Proton. Subatomic particle with unit positive charge. Its mass is equal to one hydrogen atom. Neutron. Subatomic particle with no charge. Its mass is equal to one hydrogen atom. Atomic structure. Center part of an atom is the nucleus. Protons and neutrons are present in the nucleus. Electrons are present outside nucleus in different shells or orbits. Atoms are electrically neutral. Number of positive charge is equal to number of negative charge. That is, number of protons is often equals to number of electrons. Atomic number, or Z. Number of protons present in the nucleus of an atom is referred as the atomic number. The number of protons are generally equal to the number of electrons. Thus, Z can denote number of protons as well as number of electrons. Atomic number uniquely identifies the element. Here, in the diagram, we can see that it has 4 protons. Thus, its atomic number is 4. Mass number denoted by A. Total number of protons and neutrons present in the nucleus of an atom is referred as mass number. Number of neutrons is mass number subtracted by atomic number, that is A minus Z. In the above diagram, we can notice that the nucleus has 6 protons and 6 neutrons, that is the mass number is 12. Here is denotion of mass number and atomic number of first 20 elements of periodic table. Isotopes. Atoms have same atomic number but different mass number. Isotopes are atoms of same elements which has same atomic number but different mass number. That is, they have same number of protons but different number of neutrons. They have same number of electrons and also show same chemical behavior. Examples of isotopes are hydrogen, carbon and chlorine. Hydrogen possesses 3 isotopes. Carbon possesses 3 isotopes and chlorine possesses 2 isotopes. Electronic configuration. Distribution of electrons in different shell is referred as electronic configuration. Electrons are present in different shells outside the nucleus. The electron shells are labeled as K, L, M, N, O, P, Q, or shell number 1, 2, 3, 4, 5, 6, 7, going from innermost shell to outwards. Electron shells. Each shell has definite capacity of holding electrons. The first shell has the capacity to hold 2 electrons. The second shell has the capacity of holding 8 electrons. The third shell has the capacity of holding 18 electrons. The capacity of holding electrons can be given by the formula 2n square, which is referred as 2n square rule. Oxygen. The K shell of oxygen has 2 electrons, while the L shell of oxygen has 6 electrons, and total oxygen has 8 electrons. Chlorine. The first cell, that is the K shell of chlorine, has 2 electrons. The second shell, that is the L shell of chlorine, has 8 electrons, while the third shell, that is the M shell, has 7 electrons. Sodium. First cell contains 2 electrons, second shell contains 8 electrons, and third shell contains 1 electron. Argon. Argon electronic configuration is 288. It has total 18 electrons with first orbit containing 2 electrons, second and third orbits containing 8 and 8 electrons respectively. Octet rule. Outermost shell can have maximum 8 electrons. Atoms having fewer than 8 electrons in the outermost shell have the tendency to gain, lose or share electrons to have 8 electrons in the last shell. 8 electrons in the last shell is the stable configuration. Configuration of noble gas. Noble gases have stable configuration. 8 electrons in the last shell. Their inertness is due to their stable configuration. They can neither lose or gain electrons. Complete last shell. Last shell of an atom cannot have more than 8 electrons. 8 electrons in the last shell means a complete last shell. Noble gases has complete last shell. Helium with 2 electrons in the first shell has complete last shell and is inert. Why do atoms combine? Atom combines to achieve the stable configuration of their nearest noble gas, to have 8 electrons in their last shell. Argon with electronic configuration 288. Potassium with electronic configuration 288 and atomic number 19. Calcium with atomic number 20 and electronic configuration to be 2882. No atom can have more than 8 electrons in the last shell according to the octet rule. Valence shell. Outermost shell of an atom is referred as valence shell. Electrons present in the valence shell are valence electrons. Metal nonmetals are identified from the number of valence electrons. Identification of metal and nonmetals. Metals have 1, 2 or 3 valence electrons, while the nonmetals have 4, 5, 6 or 7 valence electrons. Metals have 1, 2 or 3 valence electrons. Metal lose electrons to achieve the stable configuration. Valency of metal is the number of electrons it loses to have 8 electrons in the last shell. The number of valence electrons is the valency of metal. Magnesium has electronic configuration 282. In order to be stable, it needs to lose 2 electrons from its outermost shell. Thus, the valency of magnesium is 2. Aluminium with electronic configuration 283 needs to lose 3 electrons from its outermost shell to gain a stable configuration. Thus, its valency is 3. Sodium with electronic configuration 281 needs to lose 1 electron from its outermost shell in order to obtain stability. Thus, its valency is 1. Nonmetals have 4, 5, 6 or 7 valence electrons. They gain or share electrons to have 8 electrons in the last shell. Valency is the number of electrons gained or shared to have the stable configuration. The valency of nonmetals is 8 minus the number of valence electrons in the outermost shell. Oxygen, its electronic configuration is 2 and 6. It needs 2 more electrons to be stable at the outermost shell. Thus, its valency is 2. Chlorine, with its configuration be 2, 8 and 7. Thus, its valency is 8 minus the number of valence electrons, that is 7, that is equals to 1. Nitrogen 2, 5 is its electronic configuration. Thus, the valency of nitrogen is 8 minus 5, that is 3. Chemical bonding. In this chapter, we'll study about electrovalent bond, its definition, atomic orbit structure of electrovalent bond, covalent bond, its definition, and orbit structure of covalent molecules. Why do atoms combine? Atom combines to achieve stable configuration of nearest noble gas, helium, neon, or argon. How do atoms gain stable configuration? By losing electrons, by gaining electrons, and by sharing electrons. Which atom loses electron or gain or share electron? Metal atoms gain stability by losing electrons. Non-metal atoms gain stability by gaining electrons from metals. or sharing electron with another non-metal atom. Cation. Metal atom loses electron present in the last shell. Number of proton exceeds the number of electron. The atom changes into positive ion. The positive ion is known as cation. Cation formation. Metal atom loses valence electron to form cation. Anion. Non-metal atom gains electron to have 8 electrons in the last shell. Number of electrons exceeds the number of protons. The atom changes into negative ion. The negative ion is known as anion. Anion formation. Non-metal atom gains electron to form an ion. Neutral atom. Loss of electrons leads to formation of cation, while gain of electrons leads to formation of an ion. When metal combines with non-metal, metal gives out the electron, non-metal takes the electron. Electrovalent bond. The bond between cation and anion. Electrovalent compound. Metal loses electron, forms a cation. Non-metal gains the electrons, forms the anion. Force of attraction develops between cation and anion. Electrovalent or ionic bond is formed. The compound is electrovalent compound, and all metal compounds are electrovalent. Covalent bond. Bond formed by sharing of electrons. When two non-metallic atoms combine, they share electrons to have 8 electrons in the last shell. Each atom contributes equal number of electrons to the shared pair. The bond formed by sharing is covalent bond. The compound is covalent compound, and covalent compounds are compounds of nonmetals. Electrovalent compounds are made up of ions, while covalent compounds are made up of molecules. Orbit structure of electrovalent compound. Example 1, sodium chloride. Sodium, electronic configuration 281. Chlorine, electronic configuration 287. Sodium cation Na+1, electronic configuration 28. Chloride ion Cl-1, electronic configuration 288. Thus, they both have stable configuration and they form the compound sodium chloride Na+1 Cl-1. Magnesium chloride Mg+2 Cl-1 whole twice. One magnesium ion shares its electron with two chloride ions to form magnesium chloride. Calcium oxide. One calcium atom gives 2 electrons to one oxygen atom to form calcium oxide, Ca2 plus O2 minus. Orbit structure of covalent molecule. Water. 2 hydrogen atoms share its electron with one oxygen atom to form water, H2O, leaving 2 lone pairs to oxygen. Orbit structure of nitrogen. Triple bond between 2 nitrogen atoms. 2 nitrogen shares 3 electrons each to form N2 with triple bond.